Okay, in this video, we're going to look at evaluating a function using function notation, something that we're going to see a lot of throughout the remainder of this course. So again, think of a function as a machine, like a vending machine, a cell phone, a computer, a car. I mean, just a machine where you give the function, the machine, some input value. It's going to process that value according to what it was designed to do, and then it's going to return a value back to you as output. So for instance, let's say we have a function that squares whatever you give it, so x squared. So if we give the x squared function a 10, it's going to take that 10, square it, it's going to process it and square it, and then give us back the result, which is 100. So here we have a simple machine that just squares whatever you give it, and if we give it a 10, it'll square it, give us out 100 in return. If we give it a 15, it'll square it and give us 225 in return. So all it does is processes some input, some information, and gives us back some output in return. So a function can be described using function notation because we don't want to necessarily have to draw out pictures every time we want to represent a function. So f of x, and this is what it's read, is f parentheses x, read f of x, represents the value of the function when we plug whatever value of x is into it. So in previous math courses, you might have had something like evaluate x squared when x equals 10. Well, this is just a little bit of a higher level approach to that, and we would say f of x equals x squared, and we can evaluate f of 10. Now, we're not limited to just using f and x for our function. We can use other notations as well. So we can use g of x or h of x. We can even use, instead of x, we can use whatever letter we like. We can use n if we want to. We can use t. We can even use happy faces and symbols. So we're not limited to just only having f of x, but the most common by far representation for a function would be f of x. But it is nice to have other representations because if I want to graph separate functions on a graphing calculator, I can't name them all f of x. So I'd have to change them up, maybe using g of x and h of x, or maybe even using little subscripts like f and then sub 1 of x and then f sub 2 of x just to distinguish them. So when we substitute a value in for the variable and then evaluate it, that's called evaluating the function. So for instance, again, we might have had in prior math courses something like evaluate x squared when x equals 10. Well, here we're going to do the exact same thing. It's just we're going to use function notation instead of writing out evaluate whatever the function is when x equals whatever number it is. All right, so here's what it looks like. It says evaluate f of 2, f of negative 2, and f of 0 for each. So here we have f of x equals 2x plus 3. This is our function. This is our machine. And what f's whole purpose in life is in this example is to take whatever you give it, multiply it by 2, and then add 3 to that result. And whatever the number is, that's what it's going to give you back in return. So this function's whole purpose in life is to double whatever you give it and then add 3 to that result and give you back whatever the result is. So f of 2 means we're going to plug a 2 in for x and do 2 times 2 plus 3. So whatever number's inside this parentheses on the left, we plug into that variable on the right. So f of 2, take 2 times 2 and then add 3 to it. We get 7. So it's going to double 2 to get 4, add 3 to 4 to give us back 7. For f of negative 2, we're going to double negative 2 and then add 3. So 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. So we give our function, our machine, a negative 2. It gives us back a negative 1. Finally, when we give our function a 0, 2 times 0 plus 3 gives us back a 3. So here's our 3 values for example 3a. For example 3b, we have f of x equals 3x squared minus 1. So now we have a function whose whole purpose in life is to square whatever you give it, then multiply that result by 3, and then subtract 1. So remember our order of operations, we got to do our exponents before our multiplication. So this one is going to square whatever we give it, multiply that by 3, and then subtract 1 from that result, and give us back whatever the answer is. So f of 2, we're going to take 2 and square it, then multiply that by 3 and subtract 1. So 2 squared is 4, 3 times 4 is 12, 12 minus 1 gives us 11. So we give this function a 2, it gives us back an 11. F of negative 2, 3 times negative 2 squared minus 1. Again, order of operations, negative 2 squared. If you put this in a calculator, make sure you put the negative 2 in parentheses and then the exponent outside. So it has to look identical to what's here. Negative 2 squared is actually positive 4. 3 times 4 minus 1, as we saw, is 11. And then f of 0, if we give our function a 0, 3 times 0 squared minus 1, 0 squared is 0, 3 times 0 is 0, and 0 minus 1 gives us back negative 1. Visually, what's happening is if we graph this function, when our x value of 2 on the graph has a y value of 11, our x value of negative 2 on the graph also has a y value of 11, and our x value of 0 on the graph has a y value of negative 1. So part C, when we look at f of 2, we're going to find our x-coordinate of 2 on this blue graph, and it's all the way here, and the y-coordinate of this point is 3. So f of 2 is 3. F of negative 2, if we go to negative 2 and find where our graph is for negative 2, our graph is right here, which also has a coordinate of 3. And then for f of 0, that's when x is 0, that's at the origin, we're going to look at where the graph is, and our graph is right here, which has a y-coordinate of negative 1. So from a visual perspective, when you evaluate a function, you're finding what the y-coordinate is for that x-coordinate that you plug in. In other words, the output is the y-coordinate, the input is the x-coordinate, and what's the ordered pair for x and y on that graph. So that's all you're really doing. All right, so that about does it for this video. Thank you for watching. I'll see you.